Hello, this is Madhat Al-Masri. In today's video, I will demonstrate how to build a basic MCP server with Azure Functions. We will first build it locally using Azure Functions core tools. After testing it in VS Code with Copilot chat, we will then deploy it to Azure using the Azure CLI tools. In order to continue on, you will need to have a GitHub account. You also need Visual Studio Code with Azure Tools extension. You will need .NET 9 or later. Also, we will first build the application using Azure Functions core tools. Later on, in order to deploy it, we will need the Azure CLI tools. And of course, if you want to go through the deployment process, you will need to have an Azure subscription. As far as the Azure tools are concerned, you need to install Azure Functions core tools. And the command for that is npm install, and you would install it globally. So you put in the switch -g, and the actual tool is Azure-functions-core-tools, and you want to get the latest version. And to install the Azure CLI tool, you will need to go to this link. You can find out if you have the Azure Functions core tools by simply typing in func --version, and it will tell you what version you've got. I've got 4.2.2. To find out the version of the Azure CLI tools, I'll just enter AZ --version. And the version I have is 2.77.0. The version of .NET that I have is 9.0.304. So let's get started building our MCP Azure Functions application. The first thing to do is I'm going to create a directory called remote mcp func, and I'll go into that directory. And I'll open this folder in VS Code with code. If you install the Azure extensions for VS Code, you will have this option here, Azure. And to create a new Azure Functions project, you can click on the Thunderbolt here and choose Create New Project. It's going to ask you, do you want to use the current folder? And in my case, I'm going to say yes. And which language do you want to use? I'm going to use C#. And the runtime at the moment, I will be using .NET 9 isolated. The type of project I will be creating will use the HTTP trigger, so I'll choose that. For the name, I will call it simply HTTP MCP. Hit enter. The namespace, I will just call it mcp.function. Hit enter there. I will be using anonymous authentication. It created the project pretty quickly. Now, if I go into a terminal window at that location and type in func start, it will start for me the Azure Functions application. And it gives me an endpoint. So if I go to this endpoint in a browser, so at that endpoint, this is what we see. It says, welcome to Azure Functions. Let us do something not only more interesting, but we'll turn this into an MCP server. I will hit a Control-C here to stop the server, and we will install the one and only package that we need to turn this into an MCP server. And the package we will need is microsoft.azure.functions.worker.extensions.mcp. So I will add this package to my project. We will add 3 simple MCP server functions with these abilities. The first one is just going to reverse a message. The second one will multiply 2 numbers and give us the result. And the third one will get the animal associated with the zodiac calendar given a year. So if we give it the year 2026, it should come back and say that is the year of the horse. So let's get started to code our application. I will go to the Solution Explorer tab, which comes when you install the C# DevKit extension in VS Code. And in here, I will create a folder called MCP Tools. I'll click on that and type in MCP Tools. And in here, I will start off by creating a file that will contain some of my constant string definitions. And I will call that file tool definitions. And that will be a C# class. You can copy the code for this class from this gist. And I will be putting the links to all of the gists we'll be using below the video. And here it is. I will click on the row button at the top right hand corner and just grab all this code and put it in here. If you look at the MCP tool definitions, it's got an inner class called ReverseMessageMcpTool, another one called MultiplyNumbersMcpTool, a third one called ZodiacMcpTool, and a final one called DataTypes. And these are all actually string constants. And the reason I put them all in this file is it sort of helps to manage all these strings all in one place. So let's take the first one, ReverseMessageMcpTool. The name of the tool is ReverseMessageMcpTool. The description is it echoes back message in reverse. These descriptions are important because they do help the AI model in determining which tool to call. The parameter that's going to be used when we call the reverse message tool is a message, and the description of that message is it is the message that's going to be reversed. The second tool is MultiplyNumbersMcpTool, and the description is it's a tool that shows parameter usage by asking for two numbers and multiplying them together. So there are really two parameters. The first one is param1, and the name is first number, and the description is the first number to multiply. And then you have param2, the name is second number, and the description is the second number to multiply. The third tool, which is the Zodiac tool, the name is simply called Zodiac tool, and the description is it returns the zodiac animal associated with the given year. It takes one parameter, and that is a year, and the description is the year to get the zodiac animal for. Now we have really two data types here. One is number and one is string. Let us start by defining our first reverse message tool. I will create a C# class and I will call it ReverseMessageMcpTool. The source code for the ReverseMessageMcpTool can be found at this gist. I'm going to click on row and copy this code, paste it here. I will first resolve all of these namespaces. So there must be a run method, and that run method takes two parameters, the context and the message. The context is annotated with MCP tool trigger, which has a name and a description, which is called from the tool definitions file. And the second parameter message is annotated with MCP tool property, which has a name, a data type, which is string, and a description. The business logic for this method run is the work that needs to be done. So we're going to take the input message string and we're going to reverse it, and that returns this reverse message string, and we're going to return a string saying, hi, I am reverse message MCP tool, for example, and the reverse message is whatever that is. So we've done our first reverse message MCP tool. The next tool we want to do is the one that multiplies two numbers. And for that, I will add yet another tool here. It's a class, and I will call it MultiplyNumbersMcpTool. The source code for that can be found at this gist. Going to that gist, copy this, and come over and put it into the MultiplyNumbersMcpTool class. And as usual, we will resolve all the namespaces. Looking at this code, just like the previous class, the run method takes a context and the inputs. In this case, we have two inputs. We have a first number and a second number. Each input is annotated with MCP tool property, and the result is simply we're going to multiply the first number with the second number and return that in the result, as you can see here. Let's do our final MCP tool, and that is the Zodiac tool. So let us add a third tool here, and we're going to create a class, and we'll call it the Zodiac MCP tool. The code for the Zodiac MCP tool can be found at this gist. Here is the source code. I'm going to copy it and put it in my VS Code and resolve the namespaces. This is very similar to the previous tools, but I have a helper method here that takes an integer year and it returns the animal associated with that year. The run method, it takes context as a parameter and it's got only one input, and that is simply the year, and the year is of data type number. What we return is a message saying the zodiac animal for the year so and so is, and we call this helper method, pass it the year, and it gives us the name of the animal. We've done 3 tools. Before we can test anything, we have to put in some code inside of our program.cs to indicate that this is actually an MCP server. So let's go into our program.cs, and right before this final line, we're going to put this code to say builder enable MCP tool metadata. This basically inspects the assembly and identifies all the tools and turns this thing into an MCP server. Another thing we need to do in development is to go to the local settings.json and set the value for Azure Web Job Storage to this value, use development storage equals to true. And this is simply to use the Azure emulator for local development. Also, in this block of values, we want to add another setting. The purpose of this is to use the local file system for secrets instead of blob storage. Let's start our Azure functions in the emulator. So I can do a func start, and the most important endpoint we should be looking at is this one right here. Let's copy that and put it in an editor. We will be using this later on to test out our MCP tools from within VS Code. Further down, you can see that we do have 3 tools. Let's keep this running as we proceed. In VS Code, you want to go into the GitHub Copilot chat, choose agent, and I'm going to choose Claude Sonnet 4. Then click on View Command Palette and choose MCP Add Server. We're going to use HTTP with server sent events. Choose that, and then back where we saved that endpoint, you want to tag to it SSE, copy this and paste it here as the MCP URL. Hit enter. Here we specify a name for our MCP server. We can just call it my MCP Functions server. Hit enter there. I prefer making it local to this application, so I'm going to choose workspace, and I get this dialog. I'm going to say trust, and you get this file that gets created under .vs code. You have a file called mcp.json. You can see that the server is running. We can stop it and we can start it again. You can click on this tools icon. If you go to the very bottom here, you will see that indeed the my MCP function server is running, and there are 3 tools here. I can close this and let's test it out. I will start by entering this prompt. reverse the message. MCP is very cool. It finds the MCP server. I'm going to click on allow. It does find the reverse message tool, which reverses the string. And it comes with the result saying MCP is very cool, and the reversed message is this. Let's try another prompt. I'm going to ask it to multiply 189. And again, it's going to find the tool. I'll click on allow, and it comes back with this result. Finally, I'm going to ask it this prompt. What is the animal associated with the year 2025 in the Zodiac calendar? Sure enough, it found our Zodiac tool. Let me click on allow. The result is the Zodiac animal for the year 2025 is the snake. In the Chinese Zodiac calendar, 2025 is the year of the snake. People born in the year of the snake are often considered to be wise, intuitive, and mysterious. So not only did it use the tool, but it also used one of the AI models to complement that information with the information about the character of the person born in 2025. We have built our MCP tools in Azure Functions. We tested them out in the emulator. We need to deploy them to Azure. So for that, you need to have the AZ tool. I will stop the emulator here and log in using the AZ tool to Azure. And when I do that, it's going to ask me to log in the browser. It displays the subscriptions that I have, and I'm going to choose one. And at this point, I am logged in. I will next create a resource group on Azure with this command, az group create and the name of the resource group, and I will set the location to be East US. So let me hit enter here. This indicates that I have indeed created a resource group under my subscription. Next, I will create a storage account on Azure. So the command for that is az storage account create, and this is the name of my storage account. I prefixed it with my initials, and the resource group that's going to be used is the one that I created before. The location is East US. On this queue is the standard LRS. So let me hit enter here. This takes a bit of time, so be patient. In the end, you will see some JSON output, which indicates that it was successful. The next instruction is to create a functions app. Az functions app, create in this resource group that we mentioned before, and consumption plan location is East US. The runtime is .NET, and we want to use functions version 4. The name of the functions app is MCP Functions App, prefixed with my initials, and the storage account is the storage account we created before. Hit enter here. Again, this could take maybe half a minute or so. This indicates that it was successful. The final step is to publish our functions app with this command, func Azure Functions App publish. And let me hit enter there. And you can see here that it says starting the function app deployment. And basically it's uploading our functions app to Azure. Here the message says deployment completed successfully. It's syncing the triggers and it's looking good. Let us go now to Azure and see what has happened. I logged into Azure and I'm looking at my function app. And you can see here that we have 3 tools: MultiplyNumbers.MCpTool, ReverseMessageMcpTool, and ZodiacMcpTool. I will copy the domain of my tool and also paste it in Notepad right here. We need to have a key in order to interact with this Azure function. So go back to your Azure function, click on App Keys, and copy this key beside MCP extension and save it somewhere because you will need it later on. Back in VS Code, you want to go to your mcp.json file, delete this, and we will add this chunk of JSON at the very top. Basically, you're indicating here that when you test this out, VS Code is going to prompt you for a string, which is the function's MCP extension system key. And this is the description. The password is true, meaning it's going to mask the password. And one more thing we want to do is that we'll add some more JSON under our server configuration, and it looks like this. This requires that in order to run the server, it has to prompt us for this key, and you can see here that the input is functions MCP extension system key, which matches this. Now we should be able to test this. If we restart the server, it's going to ask us for our Azure key. I copied my Azure key in the clipboard and I'm going to paste it here. And you can see, because we said it's a password, it's going to mask it. And let's hit enter. You can see now that our server has started. So let's give it a prompt. The prompt is multiply 11 and 22 and provide the answer. It should find our MCP server, and it did find it. Now it's interacting with the deployed version of our Azure Functions, which is also an MCP server. And here you go, it gave us the results. 11 times 22 is 242. I hope you found this video useful, and if you did, please give it the thumbs up, and it would help if you subscribe to my channel. Until I see you next time in the next video, good luck and all the best.